Alright, welcome back guys. This is our second to last video lecture of the year. May 15th would have been the day when we would have had the last day of school. So we will adjourn with the lectures after Thursday. So I think there is some student textbook drop off, which for you guys don't get a textbook coming up this week though for other classes. So keep posted to the emails and or notices by the school out there for you on that subject. But thank you guys for tuning in. I know it's been a wild ride here the last couple months, so I really appreciate you guys taking the time to watch the videos, tune in each week, and do the work. I know it's not easy, so thank you. But we're going to finish up talking about Chapter 3 today. There is no quizzes, there's no discussion board, only the activities that I have assigned for you. There's one today with a simulation about ecosystems. It seems pretty basic at first, but it's definitely a lot harder than it looks. So I'll be talking about that at the end of the video for you. But today we're going to get on with the show, talking about communities, biomes, and ecosystems for the aquatic ecosystems. And those are pretty important, and we're going to discuss why they are so important. So our objectives are to identify the major abiotic factors that determine the aquatic ecosystems, recognize that freshwater ecosystems are characterized by depth and water flow, identify transitional aquatic ecosystems and their importance, and distinguish the zones of marine ecosystems. Main idea: aquatic ecosystems are grouped based on abiotic, non-living factors such as water flow, depth, distance from the shore, salinity, and latitude. So water itself, as we know, is a very valuable and essential thing that we need here on Earth. 75% of our planet's surface is actually covered in water. However, the water that we see is actually not always drinkable because it's salt water. Many things on Earth require some form of water. It is a great solvent, which means it allows for lots of proteins, chemicals, and things to dissolve within it so we can live our healthy lives and maintain homeostasis. Scientists even believe that life began in water. That's how important it is, and that's why as we venture out and start looking at other planets in our galaxy, that we're looking for the planet to have certain criteria. It has to be in the Goldilocks zone, which means it's not too far away from the sun or too close to the sun, that it has to have a rocky surface, and water. If it has water, we think that it has a greater chance of having life on that planet. So that's why we're always looking for these certain criteria when we look for planets out there. The majority of Earth's water, however, is salt water. Only a very, very small percentage actually is fresh water. So as we look at the diagram, pie chart at the top, 97% is salt water. Only 2.5% of that is fresh water. As we look down here, we divide out just the fresh water. 68% of it, almost 70%, is in glaciers, which means it's locked away in ice. The ice caps either the North Pole or down there in Antarctica. There's groundwater, which is 30%, which is out there, and that could be like aquifers and stuff like that. But then we have lakes and rivers, which make up like 0.3%. When you think about where the majority of people just in the United States get their water from, it's from a lake or a river. And that makes up 0.3% of the fresh drinkable water for the human species. But again, the human species, yeah, we may be 7-8 billion people on Earth, but at the same time, there's a lot of deer, raccoons, birds, all that need fresh water too. So all that water has to be used by not just humans, all organisms that live on land pretty much. So pretty crazy when you think about how important water is and how small amount of it there is. That's fresh, plain drinking water. There are three major aquatic ecosystems that we're going to talk about. You have the freshwater ecosystems, you have the transitional aquatic ecosystems, and the marine ecosystems. So the freshwater, there are two main types of freshwater ecosystems. You have the rivers and streams, which flow from the headwaters to the mouth. So that's just some terminology we use when we talk about a river or stream. It has its headwater, which is where the stream or river begins. Even the Missouri River, right? It has a headwater. If you didn't know, it actually starts in Montana, way up there in Montana in the mountains. And then it gets bigger and bigger and eventually makes it all the way down here to Missouri and then dumps into the Mississippi, which dumps into the Gulf. Whew. So yeah, the mouth of Missouri would be down there by like St. Louis. We have lakes and ponds, which are inland bodies of standing water. So they usually have water year round, usually even within drought too. Their water source may go down, but should still have some to support life, as compared to a river or stream that could dry up and then have just isolated pockets and may not support life as efficiently. Okay, so we got those. And those are pretty important because a lot of these is where we get our drinking water from. So we got to make sure that we keep these things clean, healthy, and safe for ourselves. You have freshwater zones. So you have the littoral, which is the area closest to the shore. So if you're out there at the lake next time, the area close to the shore with shallow water, it has an abundance of light. You can probably see the bottom. Maybe get a little murky, but you should be able to see it. Plants are growing there. It's great. So lots of producers, a lot of phytoplankton, stuff like that. We're going to have the most life teeming there. That's probably in microorganisms or in plant life. You then have the limnetic zone, the open water area, still high up in the water column, but it's well lit and lots of plankton. So that means is if you're at the beach, you're staying at the edge, you're in the littoral zone. You start to swim out and get about chest high, now you're talking about the limnetic zone. You start swimming out even farther. You go out in the middle of the lake. You're still on the surface, right up there the water. That's still the limnetic zone. All right, so light will actually from the sun will penetrate into the water so many feet. After a while, it stops. It can't go any deeper because of the sediments, the depth of the water, whatever it may be. And usually you can feel that thermocline as you swim out there, and your buddies tell you, "Hey, see if you can touch the bottom." That thermocline, as you start to swim down, it gets colder and colder. All of a sudden, it's like bam, hits a brick wall, the cold zone. That's the thermocline where it changes. So the sunlight is not penetrating any deeper than that usually. All right, so you have the profundal zone, which is the deepest areas of a large lake, much colder, lower levels of O2, little sunlight, and fewer animals live there. You might think, why do fewer animals live down there? Again, if there's no producers like in the trophic pyramid, you can't support as many organisms. So it's dictated by the amount of food that's usually either falling down or the other smaller organisms that venture down there for whatever reason. So not many organisms live there. All right. So that's the profundal, the deep down zone. So this was, say, your lake here. You're standing here fishing. You're going to fish right here next to the littoral zone. You may even be able to cast way out there to the limnetic zone, the open water. But as you dive deep down here, that's the profundal zone. Deep, 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 deep down there. You can see that right here, there's no more plants growing and whatnot. The benthic zone is just a lot of dead sediments and organisms build up over time right through here. All right. So you have the transitional aquatic ecosystems. Some aquatic areas don't appear to be a stream or lake. And like, well, it's not really a stream or lake, but it has standing water usually. But it's only like maybe 2-3 feet deep, always. These areas are transitional areas that are combinations of both. These can include wetlands. A wetland area is usually a swamp, marsh, or bog, and they just have water out there. And it's usually sometimes seasonal, from spring when the ice melts, or just lots of rain. A lot of ducks and geese like to land on this because it has vegetation coming through that may have food for them, so they can eat there, but yet it's not too deep for them either. So they can always make it to land, find cover and stuff like that. So if you're a duck hunter, you've probably seen things like this. There's also estuaries. Once again, you've got different areas where rivers and streams are starting to overflow in certain lowland areas. Okay. Wetlands, saturated with water, but still supports aquatic plants. So lots and lots and lots of water, no matter where you go, but plants are still abundant and growing there. The soil may not ever get like super high up, not big mounds and stuff like that. You're looking at certain pockets. It's probably very muddy if you try to walk through it. Estuaries are an area where fresh water from a river or stream merges with the salt water in the ocean. It is so diverse the ecosystems are rivaled only by the rainforest and coral reefs for the diversity of life found within them. Because some of the organisms may be freshwater, some of them may be saltwater, and you have those that are in between. It's just super awesome to see some of these things and the different organisms live there. You can see here there's the mouth of kind of the river stream in this photo here in the lower left, and as it ventures out, all these sediments that have washed away from erosion are starting to be deposited. And it's not like it's super high elevation, it's just starting to build up sediments enough so that plants can take root, and it's creating these little islands, so to say, of vegetation. and the water just trickles through there. If you've ever watched, say, the Duck Dynasty shows back in the day, or Swamp People on the History Channel, you always see them in these estuary type areas that have lots of trees growing there, swamps. It's like I said, 3 or 4 feet deep. They've got alligators growing there. They got snakes. They got all sorts of crazy stuff that's just gathering in these areas. So very, very cool areas, very diverse. As compared to the marine ecosystems, the oceans. If you've ever watched Finding Nemo, they do a really good job, believe it or not, of talking about the marine ecosystems and how there's different things. They start off in the coral reef area and how it grew over time, and they've got the open waters out there, and you know how they were swimming in the daylight. You could see them, but then they went down, way down in the ocean, to those trenches, and they found the anglerfish, which is kind of cool because there's no light. So they got some pretty cool aspects of the ecosystem actually built in there. So algae in the ocean actually produce roughly 50% of Earth's oxygen. So when we think about Earth and how we get all this oxygen from trees and plants, we're like, wow, yeah, good job, plants. A lot of people don't take into account that 50% of that oxygen that you're breathing is actually made by algae in the ocean. Yeah, remember, 75% of our planet's surface is covered in water. There's these algae that grow and produce this oxygen because they're photosynthetic producers. There's like a giant rainforest essentially in the ocean that's producing all sorts of things for us. The majority of water vapor in the air that produces precipitation comes from the ocean. So when we think about the rain that we're going to be getting this week, a lot of that rain came from the ocean. Now, again, it came up from probably the Gulf or the East Coast. If we get precipitation as in snow, usually it came from the Pacific, moved away across Canada through North America to us. So all that's pretty much from the ocean. Now, the ocean zones are a little different than, say, a lake zones. They just name it a little different because they're a little more diverse and a lot deeper. You have the pelagic zone, which has the photic and aphotic zone. And the word photo means light, so it's also called the euphotic zone. It's shallow enough that sunlight penetrates through it in the photic zone, which means, hey, good. We've got probably a lot of producers there, made up of the epipelagic zone and the mesopelagic zones. The aphotic zone is an area where the sunlight is unable to penetrate, so we have probably fewer producers, fewer organisms living there. There are still quite a few. You also have the abyssal zone, the deepest region of the ocean. Most organisms rely on things drifting down from above, usually dead things, and there's not very many of them down there. So this is why you're like, oh, you know, the megalodon might still be out there. Well, it's possible the megalodon's been out, or may still be out there, but highly doubtful because it's a rather large organism. You're like, well, it could be living way down deep in the ocean. But again, what lives down deep in the ocean? Not many things. Yes, there might be some large things down there, but there's not many of them. And as such, this giant predator organism is going to have to eat a lot of things. So therefore, it would have to probably eat a lot of things that were down there, but there's not many, so it'd probably starve. So if you're going to see a megalodon, it's probably going to be close to the surface and in the pelagic zone, because that's where all the organisms are, but we don't see them there. We also have the benthic zone, an area along the shore that contains sand, silt, and dead organisms. And this has lots and lots of cool things. You can find some fossils and stuff that have washed in there over time and get some of those maybe megalodon teeth or whatnot. So here's a nice little cool picture from a book here. You've got over here some shallower water where you're going to find some organisms along the shoreline. And you got the epipelagic, mesopelagic, you got the aphotic, you got the abyssal zone, you got the benthic zone, which is all right here. And what you may not know is that there's what is called a continental shelf, right, and international waters. You might have heard that in movies. The question is, what determines international waters and the waters of, say, the United States? Well, each continent has a continental shelf, which means even though the water starts at the edge, as you go out, yeah, it may get deeper and deeper and deeper, and it may be, you know, close to 100 feet or something right here down below, but then all of a sudden it just goes and just drops right off the face of the Earth, basically. And it's like, what in the world? All that continental landmass has a shelf, and it gets really, really deep. So that kind of determines the waters of the United States versus international waters. Once you get to the continental edge, it's anybody's ocean at that point. So there you go. A little bit of trivia for you. This picture here is talking about the garbage patches. Um, the oceans are very important to us because we do get a lot of food from them, fish and stuff like that. We don't eat a lot of fish maybe here directly in the Midwest, but there is a lot of population along the east and west coast of the United States that still rely heavily upon the bounties that they catch from the ocean. So we are out there all the time fishing and doing that stuff. But there's also a heavy population, which means there's lots of trash. And if you walk down any road in Missouri and picked up trash, you will notice that people are very careless when it comes to picking up after themselves. So as you can imagine, that is a very common thing or theme among many people. And we go out to the beach and maybe we pack a lunch in one of those Walmart sacks and then it blows away. We're like, oh well, somebody will pick it up. Yeah, who picked it up? The ocean. So all of this trash, beach balls, chairs, you name it, fishing nets, all tend to wind up in the ocean. And they tend to congregate in these specific areas. And the question is why? Well, there's these natural currents in the ocean which swirl around, and it starts creating this swirl effect of garbage. And right out here we have the Eastern Garbage Patch. So out there's a bunch of trash just piling up. Over here there's a Western Garbage Patch. And they're just continually piling up more and more and more, which causes lots of problems for, of course, organisms out there. Sea turtles, they see a floating Walmart trash bag out there, and they're like, hey, cool, a jellyfish, which is something they eat. And they go to eat it, and guess what? It's not. And it gets clogged up in their intestines, and it's not good. So it can poison them, kill them. It's a bad deal around for a lot of the aquatic life. And this is what it kind of looks like. That's how bad it is. And it's not like, hey, we could just go out there and pick it up. A lot of plastics break down with sunlight, and it becomes very fragmented small pieces over time. So you might be able to get some of this stuff, but ultimately, it's hard to get all of it. So there are many companies out there trying to design new things to help clean up the ocean and turn this plastic into something else so we can get rid of it. There's one company out there that they take the recycled plastics and they form like little beads and they put them into a bracelet, and you can buy the bracelet for like $5 basically as a payment method to help them fund workers, new facilities, equipment and stuff to clean up the ocean. Basically it's your contribution donation. But ultimately when it's international waters, whose problem is it? No one's. No country wants to take claim or responsibility for this, even though we all contributed to it. So when it's not in your backyard, why do you care, right? Well, the world is our backyard and we should care. So as you can see, this guy's diving in it and it doesn't look too good. Some of these garbage patches can be several feet thick too, basically like a floating island. But I'd like to say those are the only two, but they're not. There are many of them starting to accumulate worldwide from ocean currents, so it's not just these two. But yeah, very sad. So next time you think about, the garbage that you have laying out and you throw it out your window when you're driving, it goes somewhere. The question is, where does it go? We should be concerned about it. So we won't talk about the review there, but just wanted to give you a little tidbit of that. Now today, the ecosystems, to wrap up and finalize everything on this, I've found a cool game from PBS, and it's called Feed the Dingo. Now, Feed the Dingo seems like a pretty simple game at first. It gives you some basic instructions and whatnot, but as you play it, let's see if we can get it pop up here. You're supposed to go through and try to get these organisms to survive. You don't have to create a lock-in or anything like that. So you're supposed to add 5 plants or animals each day. They have little icons right here that help you out and make your decisions. But give it a shot, play it. You're trying to get all these organisms in the ecosystem at day 12 and take a screenshot if you can. It's a little trickier than you think because predators will eat the prey and then they'll run out. And if they run out of food, then predators die. So you gotta be careful what you put in there as you build up to it. So give it a shot, see what you think, and we'll go from there. Again, just take a screenshot, post it in the assignment. That's all you gotta do for the day. Alright guys, if you have any questions, post in the chat. I'm gonna post the assignment for you and go from there. All right, the assignment is posted. So like I said, if you have any questions, you can ask, or you can always shoot me an email, and I'll be glad to answer any questions I can. Thank you guys for tuning in. Stay safe.